Okay, so imagine that we have the following statement as the sum of 5 consecutive numbers is even. And again, just like the last video, let's reword this into an if-then statement. If A, B, C, D, and E are consecutive numbers, then the sum is even. Okay. Now, I want to show you guys something here. Imagine if we just played around and we picked 5 consecutive numbers. How about 1 plus 2 plus 3 plus 4 plus 5? Let's do that. Well, if we do this, we get 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is indeed 15. This is not even. So even though we picked 5 consecutive numbers, so the if part was true, we found a situation where, hey look, the then part is false. So this isn't a true conditional statement. We're in that dreaded row. Remember, we can't have it where the if part is true and the then part is false. So we call this is a counterexample. To the conditional statement. So a counterexample is one example where the if part is true and the then part is false. So let's look at this in terms of quantifiers. So if you remember, if P then Q is logically equivalent, it means the same thing as all P are Q. All things that are P also have property Q. But if this isn't true, imagine that this is a false if-then statement. Well then, this is logically equivalent, so this is going to be false. So the negation of it must be true. Now remember, how do we negate an if-then statement? We change the quantifier, so it becomes there exists or there is a P that is, and we negate the property here. So we're going to change that to a not Q. So that means there's something that has property P, so P is true, but it's not Q, so Q is false. So this counterexample, a counterexample for an if-then statement, if one exists, is a situation where the if part is true and the then part is false. So here are 3 if-then statements. They're all false conditional statements. So I want you guys to pause the video now and see if you can come up with a counterexample for each of these if-then statements. Find a situation where the if part is true, but the then part is false. Okay, now that you're back, let's have a look at these. The first one, well, if a whole number is even, then the ones digit is 2, 4, 6, or 8. Well, there are infinitely many counterexamples to this, a good example would be, say, 10. So our counterexample is n is 10. And it's a good practice to tell people why that is a counterexample. So n is 2 times 5, so it's even. So the if part is true. But the ones digit is 0. So the q part is false. It's not 2, 4, 6, or 8. The second one, well, there's not too many counterexamples to this, actually. And we have to be a little bit careful, since this is a greater than, not a greater than equals to sign. Okay. So let's go ahead and see if we can come up with one. And in fact, that is it. Our counterexample will be 1. In fact, there's another one as well. Somebody else might have had 0. They're the 2 counterexamples to this. Remember, our whole numbers are the counting numbers starting at 0. So n equals 1 will do. Or you could have used 0. All you need is one counterexample to disprove an if-then statement. If you can find just one situation where the if part is true and the then part is false, then it's not a true conditional statement. So let's tell people why. So n is a whole number, of course. Or sorry, 1 is a whole number. I can write. So p is true. But 1 squared equals 1. It's not greater than 1, so q is false. And the third situation, well, if the sum of 2 whole numbers is even, then both numbers are even. And of course, our counterexample can be any 2 odd numbers, say 1 and 3. So here we have 1 plus 3 is 4, which is even. So the if part is true. But 1 is not even, so there's no way for both of them to be even. It's definitely not true that both are even. In fact, both are odd. So here, q is false. So you could either say 1 is not even, that's enough, or 3 is not even, or you could say neither 1 nor 3 is even. But anyway, these are some counterexamples to these 3 conditional statements. Let's look at the following example here. So imagine that you are, say, a liquor inspector for, I don't know, Winnipeg Folk Fest or some festival, some all-age festival. And the rule in Manitoba is if you are drinking alcohol, we'll call that P, that's the if part, then you must be 18 years or older. Let's call that the then part Q. And imagine there's 4, as the liquor inspector, there's 4 kinds of scenarios you can come across. There is a 22-year-old, a person drinking beer, a person drinking pop, and a 16-year-old. So, which ones of these would you have to check to determine if they're breaking the rules or not? So, let's look at the 22-year-old first. So the 22-year-old, we don't know if they're drinking alcohol or not. We don't know anything about P, but we do know about Q. We know that Q in this case is true. The then part is true. Okay, so let me actually number these rows. So this will be in the table 2, 3, and 4. So, if Q is true, the 22-year-old is either in row 1 or row 3. Either they're 18 plus and drinking alcohol, or 18 plus and not drinking alcohol. Remember, an if-then statement is only false when it's in the dreaded row. So person 1 is in either row 1 or row 3. Is there any way they're in the dreaded row? No. So a liquor inspector wouldn't have to check them. If they already knew they were 22, it doesn't matter what they are drinking. What about a person drinking beer? Well, a person drinking beer, that means that the if part is true. So the if part is true in rows 1 and 2. So this person would either be in row 1 or row 2. Well, there's a possibility they could be in row 2, where they're drinking alcohol, but not 18 or over. So the if part would be true, and the then part would be false. They could be a counterexample for their rule. So we would want to check person 2. So we'll put a little check mark by them. 3, well, the person drinking pop, well, that means, if they're drinking pop, that means that the if part is false. So the if part is false in rows 3 and 4. So they're in either row 3 or 4. They're drinking pop, and either they're 18 plus or they're under 18. But it doesn't matter. If you're drinking pop, then this rule doesn't apply to you. It's vacuously true no matter what if P is false. Let me put that E at the end there. So we wouldn't have to check that person. Maybe we'll use X's to say we don't have to check them, and check marks to say we do. The 16-year-old, well, the 16-year-old, are they 18 plus? They are not. So that means that the then part of this rule is false. So they're either in rows 2 or 4. So is it possibility that they're in the dreaded row 2? Absolutely. So we would have to check whether they are drinking beer or not, or alcohol, I guess, whether P is true. So we would need to check person 4. And that's pretty straightforward. I think even without talking about conditional statements and counterexamples, I think intuitively you would understand which 2 people out of the 4 you would need to check if you were the liquor inspector. Let's do another example with some cards, I guess. All right. So imagine the following thing. So these 4 cards, there's 2 sides to them, of course, they're cards. On one side is a number, on the other side is a letter. So if I took this Q and I flipped it over, I would find some number on the other side. I'm told that the rules for this card is that if the card has an even number on one side, then it has a vowel on the other. So our if part is having an even number on one side, that'll be P, and the then part will be it has a vowel on the other. This will be Q. There's no then explicitly stated, but I think it's pretty clear that you could reword this very easily just by sticking the word then in here, and it would be an if-then sentence. Okay, so we want to know which cards must we check to determine if the rule is being followed. Again, let me quickly remind you guys of the table for conditional sentences, and I'll number it the same way that I did on the last slide. So here is our table, and we'll call this 1, 2, 3, and 4. So rows 1, 2, 3, and 4. Okay. This is a good opportunity to ask you guys to pause the video and see if you can determine which of the cards must we check to determine if our rule is being followed. Okay, now that we're back, let's do the same idea that we did in the previous video. Let's look at each card and determine what rows it could be in. Well, here's a Q. A Q is not a vowel, it's a consonant. So here, the then part, which I also called Q. So this Q is just a letter. This Q is the then part. Hopefully that's not too confusing. But the then part Q, maybe I'll do that in green, is false here. The then part is false since it doesn't have a vowel on that side. Well, if it doesn't have a vowel, which rows have Q false? Row 2 and row 4. It could possibly be row 2. If it was row 2, if I turned that over and I found an even number, that would be a counterexample to my rule. If you could imagine turning this over in your mind, there's going to be a number on it. If that number was a 2, then it would have an even number on one side and a consonant on the other. So I would need to check that that's not the case. So this card I would need to check. The 3. 3 is an odd number. It's not even. So P is false. So we're either in row 3 or row 4. That's when the if part is false. There's no way we could be in that dreaded row. There's no way this could be a counterexample. So we don't need to check it. The next one, the A. A is a vowel. So here we have Q is true. And what rows have Q true in it? Well, row 1 and row 3. Row 1, row 3. So it's one of these two rows. But there's no way this can be a counterexample. There's no way it can belong to that dreaded row because the dreaded row has Q false in it, and this has Q true. So this can't be a counterexample. We don't need to check it. You could imagine if it has an even number on one side, then we're good to go. If it has the odd number on the other side, then it's just vacuously true that it satisfies the rule because this is only talking about cards with even numbers. But from our row analysis here, it's going to be in row 1 or row 3, so we don't need to check it. And finally, card 4. Well, 4 is an even number, so P is true, which means we are in rows 1 or 2. Well, this card could be in row 2. Maybe if I turn this over, it has a consonant on the other side, like a B or something. That's a possibility. It could not, but we would need to check to determine if the rule is being followed. So I would need to check the Q, because the then part is false, and I would need to check the 4, since the if part is true.